MAP4C 5.0 graphical models. So we're going to learn different types of graphical models that we've seen in previous years. Linear relations. Graph of a linear relation is a straight line, and the equation is y is equal to mx plus b, where m represents the slope and b represents the y-intercept. The rise over run definition of slope is helpful for when we have actual grid spaces that we can see and count on a graph. Whenever we just have 2 points or 2 instances in a word problem, we can use x1, y1 as our first instance or point, and x2, y2 as our second instance or point. So in this case, it would be 70 minus 50 over 3 minus 1. B is the y-intercept. In this case, the initial value, or y-intercept, is 40. Quadratic relations. The graph of a quadratic relation is a parabola. That's the U-shaped symmetrical curve that you see here. In this case, this is opening down, and we would say that this vertex is a maximum. If it were opening upward, the vertex would be a minimum. The 3 forms of a quadratic equation look like standard form, ax squared plus bx plus c, where c is the y-intercept. Vertex form, ax minus h squared plus k, where hk is the vertex, the coordinate, so it's helpful for identifying the vertex. And in factored form, ax minus r, x minus s, this is helping us find the x-intercepts of our parabola. Because when y is equal to 0, we have our x-intercepts and the zero product property. If one of these values is equal to 0, that solves for when y is equal to 0. Exponential relations. The graph of an exponential relation is an exponential curve. So we can have exponential growth or exponential decay. The characteristic that stands out to me is the horizontal asymptote. It looks like it's approaching this line but not going to cross. And similarly here, approaching but not crossing that line. So the equation, y is equal to ab to the x. A represents the initial value, where it began, on the y-axis or y-intercept. B, the growth factor, tells you that for a certain increment, what percentage growth or decay is occurring. So what number can I multiply to get from one stage to the next? So we'll see this in this context. This exponential graph shows the mass of pain medication left in a person's bloodstream after a tablet is swallowed. How much medication was initially taken? We can see that when time is equal to 0, the initial value is 500 milligrams. Determine the ratio of the mass of medication after 1 hour to the mass of medication after 0 hours. What does this value represent? So at 0 hours we have 500. At 1 hour we have 400 milligrams. So the ratio would be 400 over 500 milligrams. So 0.8 is our factor, and to verify that that makes sense, 0.8 is like 80%. After 1 hour went by, 80% of the initial value is still remaining.